Let's get right into it. Number 15. The moon is shrinking. Picture the moon sitting up there in the sky, looking all full and confident, like it owns the place. It doesn't. It's actually getting smaller, and it has been for a while, and nobody really talks about it the way they should. The moon is slowly shrinking as its interior cools down, kind of like a grape shriveling into a raisin, except the grape is 1.2 trillion cubic miles of rock, and the raisin is going to eventually destabilize parts of our tidal systems. No big deal. Here's how it works. The moon's core is cooling over time, and as it does, the entire lunar body contracts. This causes the surface to wrinkle and crack, forming what scientists call thrust faults. Basically, cliffs that form when one section of crust gets pushed up over another. Some of these cliffs have formed in geologically recent history, which tells us this process is still actively happening. We're not talking about ancient geological drama. This is ongoing. The moon is literally scrunching itself up like a piece of paper your brain is throwing in the trash. What makes this creepier is that the moon is tidally locked to Earth, meaning the same face always points at us. So all these wrinkles and fault lines are redistributing stress across the lunar surface in ways that occasionally cause, and this is the part where you tilt your head, moonquakes. Yes, the moon shakes, and some of those quakes last for hours. On Earth, a quake dissipates through water-saturated rock. The moon is bone dry, so the seismic waves just bounce around forever like a text message you wish you could unsend. Scientists who analyzed Apollo-era seismic data found quakes near some of these new faults that may still be active today. Your childhood nightlight is geologically aggressive, and it is falling apart slowly, and it has been doing this the entire time you thought it was just vibing. Basically, the moon is a senior citizen who's still somehow starting fights. Number 14. It smells like gunpowder. Nobody warned astronauts about this one. You'd think the big concerns on a moon mission would be things like oxygen, radiation, or the crushing psychological weight of floating in an infinite vacuum. But the astronauts who walked on the lunar surface and then came back into their lunar module kept noticing the same strange thing. Moon dust, the gray powdery stuff that clung to their suits and gear, smelled like spent gunpowder. Every single one of them said it. Neil Armstrong said it. Charlie Duke said it. Multiple Apollo crews confirmed it like they were all leaving the same Yelp review for a place nobody asked them to visit. The science behind this is genuinely bizarre. Moon dust, technically called regolith, is created over billions of years by meteorite impacts and solar wind bombardment pulverizing the surface into an ultrafine powder. Because the moon has no atmosphere or weather, this powder never gets rounded off by erosion the way Earth minerals do. Each grain is jagged, glassy, and sharp at a microscopic level. The moment astronauts brought it inside and it came into contact with moisture, whether from the air or from their skin, a chemical reaction occurred that produced the gunpowder-like smell. The dust was essentially reacting to contact with anything remotely alive. And that same dust is brutal. It clings to everything electrostatically. It scratches visors and equipment like sandpaper made of spite, and prolonged exposure would almost certainly cause serious lung damage similar to silicosis. The moon basically made its own passive-aggressive version of a no-trespassing sign using chemistry. You showed up, and the ground itself started reacting to your existence. That's not a rock. That's a personality. Number 13. There are hundreds of unidentified objects on it. Here's where things take a turn that the internet loves and NASA discusses with the same energy as someone changing the subject at a dinner party. Over the decades, lunar orbiters and rovers have captured images of the moon's surface that include objects, formations, and anomalies that don't have clean, boring explanations. Now, before you spiral, this isn't just alien hunters screenshotting shadows. Some of these were flagged by actual researchers and former agency insiders as genuinely unexplained. There are documented instances of transient lunar phenomena, or TLPs, flashes of light, color changes, and glowing patches that have been observed on the moon's surface for centuries. Astronomers as far back as the 1700s logged these events. NASA compiled a catalog of over 570 reported TLP incidents. The explanations range from outgassing, the moon releasing trapped gases, to meteorite impacts, to electrostatic discharges from solar activity. None of those explanations fully covers all of the cases. Some of them remain officially unexplained. Then there are the structures. There are images from lunar orbiters that show long, straight lines, geometric shadows, and what some researchers describe as tower-like formations. The reflexive scientific response is it's a trick of light and shadow, which is completely reasonable and correct most of the time, except that some of these objects cast shadows inconsistent with their surrounding terrain, which means either our understanding of the lighting geometry is off, or something is physically sticking up off the surface. The moon is 238,000 miles away. We've only explored a tiny fraction of it directly, and our best imaging still leaves enormous room for misinterpretation. The honest answer isn't it's aliens. The honest answer is we don't fully know, which somehow is creepier. Number 12. The moon has caves big enough to hold cities. Underneath the moon's surface, there are tunnels. Not small, claustrophobic tunnels that make you uncomfortable at a party when someone describes them. Enormous tunnels. Cavernous, cathedral-scale underground passages that stretch for miles, and in some cases are wide enough to fit entire cities inside them. These are called lava tubes, and they were formed billions of years ago when rivers of molten rock flowed beneath a hardened crust, eventually draining out and leaving hollow tubes behind. On Earth, lava tubes exist too, but the moon's lower gravity means the ones up there can be vastly, almost comically, larger. In 2017, researchers analyzing data from the Selene lunar orbiter discovered a lava tube near the Marius Hills region of the moon that was estimated to be over 30 miles long and potentially hundreds of meters wide. To put that in perspective, that's a naturally occurring underground hallway bigger than most cities you've actually been to. NASA and other space agencies have already started discussing these tubes as potential sites for future lunar habitats, because they provide natural shielding against radiation and micrometeorite impacts, which sounds practical and exciting until you sit with the image for a moment. Human beings living underground on the moon inside ancient volcanic tunnels in the dark. The creepy part isn't even the size. It's the unknown. We've mapped only a fraction of the lunar surface from above, and subsurface mapping is even more limited. We know the tubes exist. We do not know their full extent, how structurally stable they are, what the environment inside them looks like, or whether any of them connect to each other in ways that form larger underground networks. The moon has a secret basement, and we haven't been down there yet. Every haunted house starts exactly like that. Number 11. The moon might be hollow. Stay with me here because this one rides the line between fringe conspiracy theory and genuinely unresolved science, and that line is a lot thinner than you'd expect. After Apollo 12 landed on the moon in 1969, the astronauts intentionally crashed the ascent stage of their lunar module back onto the surface as a seismic experiment. The impact was picked up by seismometers they'd left behind, and what those instruments recorded made the scientists back on Earth go quiet in a way that wasn't exactly celebratory. The moon, according to the data, rang like a bell for nearly an hour. Some sources say closer to 2. On Earth, when you hit something solid and dense, seismic waves get absorbed relatively quickly. When you hit something hollow or something with a very different internal structure, the waves propagate and reverberate for much longer. The moon's unusual seismic response has never been completely explained by standard geological models. Later Apollo missions repeated similar experiments with larger impacts and got similar results. Prolonged, reverberating seismic signals that didn't match what you'd expect from a straightforward ball of rock. Now, hollow moon as a complete theory is considered fringe, and the mainstream scientific position is that the moon has a small, partially molten core surrounded by a mantle and crust, not empty space. But partially hollow or containing large internal voids is not off the table, and the seismic data genuinely doesn't fit neatly into any one explanation. The moon responded to being hit the way a church bell responds to being struck, with a long, resonant hum that faded slowly into silence. Whether that means something deeply unusual about its structure, or just that lunar rock behaves differently than we assumed, the fact remains that we hit our moon with a spacecraft and it sang back at us. That's not nothing. Number 10. Ancient cultures were terrified of it. Modern people look at the moon and think romance. Wolves howling, tides turning, Instagram photos with minimal editing. But if you travel back through human history far enough, the emotion attached to the moon shifts dramatically from wonder to something much closer to existential dread. Ancient cultures across the world didn't see the moon as a nightlight or a pretty backdrop. They saw it as a powerful, unpredictable, deeply dangerous force that demanded to be appeased, negotiated with, and frankly feared. In Mesopotamian tradition, the moon god Sin was considered one of the most powerful deities in the pantheon, but also one of the most mercurial. The moon's phases weren't seen as a charming celestial cycle. They were interpreted as moods. A waning moon meant the god was angry, withdrawing, or under attack by demons. Lunar eclipses were considered catastrophic omens so severe that Babylonian kings would install substitute kings during an eclipse, letting the fake king absorb whatever terrible fate the moon had planned, and then quietly getting rid of them once it was over. The moon had an entire human sacrifice workaround built around it. In other traditions, the moon was associated with madness and not metaphorically. The word lunacy literally comes from luna, the Latin word for moon, because for centuries, people believed the moon's phases directly caused mental illness and erratic behavior. Hospitals reportedly recorded more violent incidents during full moons. Judges cited the lunar cycle in legal defenses. The belief was so widespread and so persistent that it seeped into language, law, and medicine for generations before modern science pushed back on it. And even then, some studies on sleep disruption and mood shifts correlated with lunar cycles still produce results that aren't entirely dismissible. Your ancestors weren't irrational for being scared of it. They just expressed that fear by occasionally executing a replacement king, which is admittedly a lot. Number 9. The moon is way too perfect. This one is the kind of thing that, once you hear it, you'll find yourself mentioning at completely inappropriate moments like during a work meeting or a first date, because it burrows into your brain and refuses to leave quietly. The moon's size, its distance from Earth, and its orbit are configured in a way that is, mathematically, almost absurdly convenient. It is precisely the right size and precisely the right distance to produce a perfect solar eclipse, where the moon fits exactly over the sun, covering the disk almost completely while leaving the corona visible. This isn't a rough approximation. It's an almost exact geometric match. The probability of a natural satellite happening to be the exact angular size as its star, as seen from its host planet, is extraordinarily low. It's also tidally locked in a way that ensures only one face ever points toward Earth. Its orbital period matches its rotation period so precisely that we have never, in all of human history, seen the far side of the moon from Earth's surface. Not even slightly, not even on a bad day. The synchronization is perfect. Orbital mechanics can produce tidal locking, yes, but the precision here is at a level that continues to make researchers pause. The moon also stabilizes Earth's axial tilt, which is why we have relatively stable seasons instead of wild, catastrophic climate swings like Mars experiences. Without the moon, Earth's axis could wobble dramatically over thousands of years, potentially rendering large portions of the planet uninhabitable. The moon isn't just our neighbor. It's functioning as a stabilizing mechanism for the conditions that allow life to exist here. Whether that's extraordinary cosmic luck or something that demands a different kind of explanation, depends entirely on how comfortable you are with coincidence at a planetary scale. Most people, once they actually do the math, are not comfortable at all. Number 8. The moon has water and lots of it. For most of human history, the moon was considered one of the driest places in the known universe. A barren, airless, waterless rock floating in space like a geological paperweight. Scientists were pretty confident about this. Textbooks said it. Documentaries said it. Your middle school science teacher said it with the kind of certainty that makes you not ask follow-up questions. And then, in 2009, 3 separate spacecraft confirmed the presence of water ice on the moon, and the textbooks quietly started having a rough decade. The water is mostly concentrated in permanently shadowed craters near the lunar poles, places where sunlight has never reached in billions of years, where temperatures drop to around -400 degrees Fahrenheit, making them some of the coldest spots in the entire solar system. In these frozen, lightless craters, water ice has been accumulating over geological timescales, delivered by comets, asteroids, and solar wind interactions with the surface. In 2020, NASA's SOFIA observatory confirmed water molecules on the sunlit surface of the moon as well, which was somehow even more surprising, because those areas aren't cold enough to preserve ice the way the shadowed craters are. The water is there, in places it theoretically shouldn't be able to survive, and we're still working out exactly why. The reason this is creepy rather than just interesting is the implication. Water means fuel. It can be split into hydrogen and oxygen, which are rocket propellants. It means drinking water for future missions. It means the moon is suddenly a viable pit stop for deeper space travel in a way that changes the entire geometry of how humans might eventually move through the solar system. We spent decades assuming the moon was a dead end, and it turns out it was a gas station. The moon was useful this whole time and just never told us. Which is exactly the kind of thing a place with a secret basement and a grudge would do. Number 7. Something huge hit it, and we're not sure what. The leading scientific theory for how the moon formed is called the giant impact hypothesis, and it is exactly as dramatic as the name suggests. Roughly 4.5 billion years ago, a Mars-sized object, which scientists have named Theia, because apparently even hypothetical ancient planetary catastrophes get names, collided with the early Earth at an angle and with enough force to vaporize a significant portion of both bodies. The debris from this impact was launched into orbit around Earth, where it gradually coalesced under gravity into the moon. This is considered the most scientifically supported explanation for the moon's origin, and it is, by any reasonable standard, completely insane. The reason scientists favor this theory over others is because it explains several things that other theories don't, including why the moon has a very similar isotopic composition to Earth's mantle, why it has a smaller iron core relative to its size than you'd expect, and why it has the orbital characteristics it does. The giant impact hypothesis fits the data better than competing models, which is how science works, not by finding the comfortable explanation, but by finding the one that survives the most scrutiny. What's unresolved is Theia itself. We have no direct evidence of this planet beyond the circumstantial fingerprints left in lunar rock. It was absorbed, vaporized, and redistributed into the Earth and Moon so completely that it essentially ceased to exist as a separate thing. Some researchers have suggested that strange anomalies deep within Earth's mantle, two massive continent-sized blobs of unusual rock detected through seismic imaging, sitting just above the planet's core, may be remnants of Theia that never fully mixed in, which means part of an entirely different planet might be sitting inside Earth right now, and the moon might be the other part. You are technically living on the aftermath of a planetary collision, which is the most dramatic origin story anyone has ever had, and yet somehow nobody puts it on their resume. Number 6. The moon is moving away from us. Every year, the moon moves approximately 3.8 centimeters further from Earth. That doesn't sound like much. That's about the length of a paperclip. But compounded over geological time, it adds up to something that fundamentally reshapes the relationship between Earth and its only natural satellite, and it has been doing this since the moon formed. When the moon was young, it was dramatically closer to Earth, close enough that it would have appeared enormously larger in the sky, and its gravitational pull would have produced tides so extreme that ancient oceans sloshed back and forth in waves that dwarfed anything alive today. The mechanism behind the drift is tidal friction. The moon's gravity creates tidal bulges in Earth's oceans and crust. Because Earth rotates faster than the moon orbits, these bulges are slightly ahead of the moon, and their gravitational pull tugs the moon forward in its orbit, gradually increasing its orbital energy and pushing it outward. In exchange, Earth's rotation slows down very slightly. Days are getting imperceptibly longer over time. A day on early Earth was about 6 hours long. It's now 24. The moon has been slowly stealing our rotational energy for billions of years and spending it on a one-way trip away from us. Eventually, in the very distant future, on a timescale so long it becomes almost meaningless to discuss, the moon will be far enough away that total solar eclipses will no longer be possible. The moon will be too small in the sky to fully cover the sun. Those perfect, eerie, once-in-a-lifetime moments where day turns to night in the middle of the afternoon and birds get confused and the air goes cold and you feel something ancient and wordless in your chest, those will stop happening. We happen to exist at the exact window in Earth's history when the geometry works. That's either beautiful or deeply upsetting, depending on your relationship with impermanence. Possibly both simultaneously, which is a very moon thing to feel. Number 5. The far side is completely different. For the entirety of human history until 1959, nobody had ever seen the far side of the moon. Not explorers, not astronomers, not anyone with a telescope pointed upward on a clear night. The moon's tidal locking meant it rotated at exactly the rate needed to keep one face permanently turned away from Earth, and for all those thousands of years, it was simply the unknown side. Mysterious in the way that blank spaces on maps used to be mysterious back when blank spaces meant dragons or worse. Then the Soviet Luna 3 spacecraft flew around and took photographs, and the images that came back showed something unexpected. The far side of the moon looks almost nothing like the side we see. The near side of the moon is relatively smooth, with large dark plains called maria, ancient lava flows that filled in basins after massive impacts billions of years ago. The far side is almost entirely devoid of maria. It's rugged, heavily cratered, and geologically ancient in a way that the near side isn't. The crust on the far side is significantly thicker. The two hemispheres of the same object, formed at the same time, have ended up looking dramatically different, and scientists are still debating why. One leading hypothesis involves the early moon having a companion, a smaller second moon that orbited Earth alongside it before eventually drifting into the moon and colliding in slow motion, piling extra crust onto the far side. Another theory involves differences in how the early moon cooled, with the near side staying molten longer due to heat from the early Earth, allowing more volcanic activity. Neither theory is universally accepted. The far side of the moon is also the permanent radioquiet zone of the entire Earth-Moon system, which is why China landed a rover there in 2019 specifically to use it as a radio telescope site, a place so isolated from human signals that you can hear the universe more clearly. The moon has a side it kept turned away from us for billions of years, and when we finally looked at it, it raised more questions than it answered. That's either very bad science or very good storytelling, and at this point the moon is doing both on purpose. Number 4. It may have once had a magnetic field and lost it. The moon today has no global magnetic field. You cannot use a compass on the moon. If you showed up there with one, the needle would wander uselessly, because there's no planetary magnetic force to align with. This seems like a minor technical detail until you realize that Earth's magnetic field is what protects us from the full brunt of solar radiation. And without it, the surface of our planet would be a significantly less hospitable place for anything biological. The moon, by all indications, once had a magnetic field of its own, and lost it. Ancient lunar rocks brought back by Apollo missions contain evidence of magnetic alignment, meaning when those rocks solidified billions of years ago, they locked in the direction of a magnetic field that was present at the time. That field has since collapsed, likely as the moon's core cooled and its internal dynamo, the churning of liquid metal that generates a magnetic field, shut down. Some researchers estimate the moon's magnetic field may have been as strong as Earth's current one, several billion years ago, before it faded over hundreds of millions of years into nothing. What this means in practical terms is that the early moon may have been far more protected from solar wind than it is today. It may have retained a thin atmosphere for longer. It may have been, in some ancient window of time, a place with conditions that were not hospitable exactly, but less immediately hostile than the vacuum-exposed radiation-blasted surface we know now. The moon we see today is not the moon that has always been. It's a degraded version, a world that had something, lost it, and has been sitting quietly in the cold ever since, which is, as a narrative arc, uncomfortably relatable. Number 3. The moon affects your brain more than you think. Science has spent decades trying to officially debunk the idea that the moon affects human behavior, and it has done so with the energy of someone trying to close a browser tab that keeps reopening. The peer-reviewed consensus is that there is no consistent, reproducible evidence that the full moon causes crime spikes, hospital surges, or mass behavioral changes. That's the official line. And then, quietly, in a different corner of the research world, a series of studies started producing results that nobody quite knew what to do with. In 2013, a study published in Current Biology found that around the full moon, people took longer to fall asleep, slept for shorter periods, and had reduced deep sleep, even in controlled laboratory conditions with no windows, no access to moonlight, and no way to consciously know what phase the moon was in. The subjects' melatonin levels also dropped during full moon periods. The researchers themselves were reluctant to interpret this too strongly, but the signal was there, repeating in subjects who had no sensory access to the moon at all. Something internal was responding to something external that the subjects couldn't see or detect. Follow-up studies have found similar sleep disruption patterns across different populations and continents, which rules out cultural expectation as the sole explanation. One hypothesis is that humans, like many animals, carry ancient biological rhythms that evolved in sync with the lunar cycle over millions of years, remnants of an era before artificial light, when the moon was the primary source of nighttime illumination and its brightness directly governed behavior. Your ancestors hunted, hid, mated, and navigated by the moon. The full moon meant visibility, which meant predators could see you and you could see prey, and everything was happening all at once. Your nervous system may still carry that ancient alertness encoded somewhere deep, firing on schedule whether or not you're aware of it, whether or not you've ever looked up at the sky in your life. Your brain might be running lunar software from a version of humanity that predates civilization, and you're just walking around on top of it, thinking you're making independent decisions, blissfully unaware that the moon has had a standing appointment in your biology since before your species had a name for it. That's not lunacy. That's inheritance. Number 2. Someone may have been watching us from it. This is the part of the script where the tone shifts slightly, not into full conspiracy territory, but into the specific zone where credible people said credible things that got very little mainstream coverage and probably deserved more. Multiple Apollo astronauts reported strange experiences during their missions that were never fully explained, and several of them discussed these experiences publicly after leaving NASA, apparently reaching the conclusion that the professional downside of staying quiet was less appealing than it used to be. Edgar Mitchell, the 6th person to walk on the moon and a man with a doctorate from MIT, spent the latter part of his life stating openly that UFO phenomena were real and that there had been government concealment of extraterrestrial contact. Buzz Aldrin, in various interviews, described seeing something during the Apollo 11 mission that he and the crew discussed without reaching a satisfying explanation, though he was consistently careful with his wording, distinguishing between unidentified and extraterrestrial. Gordon Cooper, a Mercury and Gemini astronaut, testified before a UN panel that he had personally encountered unexplained aerial phenomena and believed the evidence warranted serious scientific investigation. Then there are the NASA transcripts. During Apollo 11's lunar orbit, there is a period of radio silence lasting roughly 2 minutes that has never been formally explained. Amateur radio operators using equipment capable of picking up the non-public frequency reported hearing the astronauts discussing lights on the lunar surface. NASA's official position is that these accounts are inaccurate or misinterpreted. Whether you believe that or not depends on where you land on the question of institutional transparency, which is a separate conversation. What is not a separate conversation is the fact that the people who actually went to the moon came back changed. Many of them in ways that went far beyond the expected psychological profile of someone who'd completed a successful government mission. Some became mystics. Some became activists. Some became very, very quiet. The moon is 238,000 miles away. We've sent 12 people to its surface. We have not been back since 1972, which is over 50 years ago, which is a gap so long that multiple generations have grown up in a world where humanity once walked on the moon and simply stopped. The official reason is budget. That might be the whole reason. But the moon has a far side we can't see, a hollow-sounding interior we don't fully understand, structures in its images that don't have clean explanations, and a collection of astronauts who went there and came back saying things that don't quite fit the triumphant narrative. Put all of that in a room and see how comfortable you are with the lights off. Number 1. We barely understand it, and we've known it the longest. Here is the most unsettling secret about the moon, and it doesn't require anomalies, conspiracy, or ancient terror to land. It just requires honesty. The moon is the single most observed object in all of human history. Every civilization on Earth looked up and saw it. Artists painted it, poets wrote about it, sailors navigated by it, priests built calendars around it. Before telescopes, before satellites, before science as a formal discipline existed, humans were watching the moon with naked eyes and recording what they saw. And after all of that, after thousands of years of observation, after multiple crewed missions, after orbiters and rovers and seismometers and sample returns, we still don't have complete answers to its most basic questions. We don't fully understand how it formed, because the giant impact hypothesis still has unresolved problems. We don't fully understand its internal structure, because the seismic data doesn't map cleanly onto the models. We don't understand why the near and far sides are so dramatically different. We don't understand the full source of its water or how it survives where it does. We don't understand the transient lunar phenomena that have been documented for centuries. We don't understand why its size and distance produce a perfect solar eclipse at this specific moment in Earth's history. We don't understand the long-term implications of its ongoing recession or the full biological effects of its cycles on Earth's living systems. We have visited 12 times. We have brought back 842 pounds of lunar rock. We have pointed every instrument we've ever built at it. And the moon has given us enough answers to feel confident and enough unanswered questions to stay humble, which is exactly the ratio of a thing that knows what it's doing. The closest, most familiar, most constantly present object in our sky has been staring back at us for as long as humans have had eyes to look, and it is still, in 2024, not fully explained. Not even close. Every generation thinks it's about to crack the moon wide open, and every generation ends up adding a few more questions to the pile. The moon is not hiding from us. It's right there, every night, same address, same face, extremely punctual. It just has the quiet confidence of something that knows you don't understand it yet, and is in absolutely no hurry to be understood. The universe's longest open secret, hanging in plain sight, patient as geology, waiting for someone to finally ask the right question. And somewhere, in a permanently shadowed crater at the lunar South Pole, in absolute silence and absolute cold, the ice just sits there, not going anywhere, not explaining itself, just waiting. That's all for today. I'll be making similar videos in the future. Subscribe to see them.